A campfire's dance, a candle's steady glow, the roar of a furnace, these are among humanity's oldest companions. Yet, within these familiar flickers lies one of nature's most profound and misunderstood dramas. To ask why fire burns is to embark on a journey that traverses the atomic, the botanical, and the celestial, revealing a hidden unity in the cosmos. Fire is not merely a destructive force or a simple tool. It is a vivid, visible expression of fundamental laws governing energy, matter, and life itself. This exploration peels back the veil on the flame, exposing the elegant, often invisible, processes that bring light and heat into being. At its heart, fire is a story of desire, a chemical yearning. The central characters are carbon and oxygen. In isolation, they exist in a state of unfulfilled potential. Oxygen atoms in the air and carbon atoms within a log are drawn to one another with a powerful affinity. Their union represents a more stable, lower energy state. When they finally snap together to form carbon dioxide, a significant amount of energy is released. However, a formidable obstacle stands in their way. To come together, they must first overcome an energetic barrier akin to rolling a boulder to the top of a hill before it can thunder down into a valley. At room temperature, the atoms simply do not jiggle with enough vigor to crest this hill. They collide and bounce apart millions of times per second in a futile dance, never quite achieving the intimate proximity required for reaction. This is why a wooden chair or a stack of books can sit for centuries in an oxygen-rich atmosphere without bursting into flame. The will is present, but the means are lacking. The transition from inert potential to vibrant conflagration requires a catalyst, activation energy. This is the initial push that sets the entire process in motion. Striking a match concentrates enough heat in a tiny area to supercharge a local cluster of atoms. Their motion becomes frantic, their collisions more violent. A few pioneering carbon and oxygen pairs, now moving with sufficient speed, finally surmount the hill. They lock together in a molecular embrace, releasing their pent-up energy. This released energy does not vanish. It transforms into furious atomic motion heat which agitates the neighboring atoms. Suddenly, these neighbors, too, have the energy to overcome the barrier. They react, releasing more heat, which agitates even more atoms. What begins as a few isolated reactions swiftly mushrooms into a catastrophic cascade. This is the essence of fire, a self-sustaining exponential chain reaction. One reaction triggers two, two trigger four, and within a heartbeat, billions of atoms are snapping together in a synchronized release of energy. The fire explodes into visibility, not because it is magical, but because it is a runaway feedback loop. The heat generated by the reactions provides the very energy needed to fuel subsequent reactions. The flame one sees is the glowing theater of this atomic recombination. The intense heat causes molecules and soot particles to become incandescent, emitting the familiar yellow and orange light. Electrons within excited atoms jump to higher energy states, and upon falling back, release photons, the shimmering dance of the flame itself. Thus, fire is not an object but a process, a violent, beautiful event where matter rapidly transitions to a more stable state, and stored energy makes a brilliant thermal exit. To comprehend what is being released, one must trace the fuel's origin. This leads to a stunning botanical truth. Consider an oak tree, its massive trunk and sprawling branches seemingly drawn from the earth. The common perception is that plants build themselves from soil. This is a profound illusion. A simple mental experiment dismantles it. Imagine weighing a pot of dry soil, planting a seed, and watering it for years until it becomes a sizable tree. If one then removes the tree and reweighs the soil, its mass would be nearly identical, save for trace minerals. The hundreds of pounds of wood, bark, and leaves did not materialize from the dirt. They were, in fact, summoned from the air. The primary building block is carbon dioxide, a gas floating invisibly in the atmosphere. Through the alchemy of photosynthesis, the tree uses sunlight as its currency to perform a remarkable feat of atomic disassembly. Photons from the sun provide the energy to meticulously tear the carbon atom away from its two oxygen partners in carbon dioxide. The carbon is kept, woven with water drawn from the ground into the complex sugars and cellulose that constitute the tree's body. The oxygen, now a waste product, is released back into the atmosphere. This process is, molecule by molecule, the exact opposite of fire. The tree is a solar-powered machine that painstakingly uses sunlight to pry carbon and oxygen apart, storing the sun's energy within the newly forged chemical bonds. The tree, therefore, is a battery, a reservoir of captured sunlight and separated atoms. Consequently, a log on a fire is not just burning wood, it is unleashing ancient sunlight. The match provides the critical nudge, and the stored solar energy, held captive for decades in molecular bonds, is liberated in a rush. The carbon, which the tree labored to separate, eagerly reunites with atmospheric oxygen. The light and warmth felt from a fireplace is literally sunlight from a distant past, re-radiated in a fiery spectacle. Every flicker is a photon of solar energy, captured by a leaf, stored as chemical potential, and finally set free. This narrative places fire within a grand, cyclical epic of life on Earth. The oxygen that fills the atmosphere, making animal life and combustion possible, is itself the cumulative exhaust of photosynthetic organisms over billions of years. Early Earth's atmosphere was largely devoid of free oxygen. It was a waste gas, even a poison, to early life forms. As plants proliferated, they transformed the planet's atmosphere, filling it with this reactive element. Animals, including humans, evolved to exploit this chemical tension. Cellular respiration, the burning of food, which are carbon-based molecules, with oxygen is fundamentally the same reaction as a wood fire. It is a controlled, enzymatic version of the same process, releasing energy not in a blaze, but in the manageable packets of adenosine triphosphate that power every thought and movement. A human body is, in a deeply chemical sense, a slow, cool, meticulously regulated fire, constantly combining carbon with oxygen and exhaling the resulting carbon dioxide. The flame, then, is a nexus point in this eternal cycle, sun to plants, which store energy by separating carbon from oxygen, to animals and fire, which release energy by recombining carbon with oxygen. Fire renders this slow, planet-sized metabolism visible and rapid. It is nature's way of closing the loop with dramatic flair. The ash left behind is the scant mineral residue from the soil, the only part of the tree that truly came from the ground, while the bulk of its substance has returned to the atmosphere as carbon dioxide and water vapor, ready to be captured by another generation of plants. Understanding fire on this level transforms it from a mundane phenomenon into a lens on universal principles. It illustrates the concept of metastability systems like wood and oxygen, or a match head, that exist in precarious equilibrium, hungry to release energy but awaiting a spark. It demonstrates the conservation and transformation of energy from radiant solar to chemical to thermal and radiant once more. It reveals the intimate dance of atomic attraction and repulsion that underpins all chemistry. To gaze into a flame, therefore, is to witness the resolution of a cosmic tension, the brilliance of stored sunlight, and the relentless, cyclical engine of life on Earth, all contained within a single, fleeting, and beautiful catastrophe of atoms finding their way home.